All right, so there's a couple of things that I wanted to go over with you. The first one is on number 2E, the equation I have here is correct. The first time I didn't realize you couldn't use the 18 and the 23. You had to use the 24 and the 17. I went over that in the first video, but what I didn't do was change my answer. So the equation is correct, and the answer is going to be approximately 0.30. That was the first one. The second one for B, I can't remember who, a couple people sent me and let me know. The question says 12 or more, and I answered it just using 68, which was the number for 12 credits only. So you're gonna need to go ahead and add 68 plus 24 on the numerator, divide by 500. That should change your probability to 0.184. And I don't think there are any other corrections, but there were a couple other questions that people sent me I thought might be good for everybody to hear. Where was it? Oh, it was question 9. Okay, and the question was 9B. Why did I multiply those probabilities together to get the final answer? And that was because that's how you find the probability of independent events, is you multiply the probabilities together. So I did it in B and I did it again in D. And then that is how, I'll skip down one more page really quick before I go back. That is how I filled out the tree at the bottom, is I just multiplied those probabilities together for yes and no. So it was only like 6 different numbers in a bunch of different configurations. And also somebody had a question. This first yes or no are the yes and no's for Colorado in this like first column. This second column is the Florida numbers, and the third column are the Maine, and I think Maine is ME. Okay, those were where we got those 3 numbers. Back up, there was one other question here. 10C, or no, sorry, 10B, I even have it circled. This 27, I would take either parameter or statistic. The reason why I changed it in the first place was because I just think what I underlined in yellow here, and I'll do it again in blue this time so you can see. Whoops. It says, thus, 27% of these works 100 residents. So I think maybe the English was a little bit off right there from what the professor meant. So my brain just wanted to read this as 27% of the residents work for the government, and it would be a parameter. I think that's where that was going. If you read it differently, kind of like I did the first time, and you thought it was still talking about those 100 residents, then it would be a statistic. If there is an issue like that on the test, as long as if you're questioning it, just put in your defense so that I know what you were thinking, and you'll get all the points for that. I wanted to share one more link that I sent, or that I put on the review page for you guys, and that is a link to this page called GeoGebra. That's pretty cool, and you can check your answers here for the binomial distributions. So what I am showing on this page is if we had our n, and I clicked in that box for n, if we're still talking about that dude, Jim was his name, that was late all the time, n was the number of times we were checking if he was late or if he was on time. P here was the probability, that was 0.65. Then if you press this middle button right here, that's the interval, and here's where you could put the 18. And then in the second box, oops, the interval is the middle one. Sorry, guys, the middle one. Why won't I click there? So the first value was 18. The second value was 23. And in this case, not like the calculator, you had to do one up and one above to get those two values actually. But here you don't, you just need to put the 18 and the 23. What's cool about this is you can actually see that histogram that I was trying to draw for you guys, okay, of this discrete distribution. And then it also gives you on the left-hand side this table, okay? And it shows you to get that probability of 0.3058, I had to hit enter to get that number. 0.3058, it's adding up everything it highlighted in purple. So it's adding up the probability of 18 times, 19 times, 20, 21, 22, and 23 times. And that's what your calculator is doing too. Another student did it differently on the TI calculator where they just put in the binomial PDF for each of those numbers and added up the answers, and that should give you the same probability. What's cool about this is look at the top left-hand side. It also has the mean and the standard deviation for you. Cool. So play around with that. See if you're comfortable with that. Don't forget, if you're using this on the test, that you're pressing enter in the right places. When you're taking the test, I would double check and just make sure it's highlighting what you wanted it to add up for you guys. Okay, I already sent out the form to let me know what time you would like to take the test. So I look forward to any more of your questions.